All right, so thank you for sticking around this afternoon and joining our session. I'm Cindy Moore,
I'm Tammy Sullivan.
and as stated, we are from Asheville, North Carolina. We were talking about bears. Our mascot is actually the Trailblazer Bear. And so our objective for today is just to share some of our favorite trig activities. We did this at AMATYC in November and had a lot of really positive feedback. A lot of our activities are things that can be done in person, but we do have adaptations since many people teach online.
And in November, we actually brought all the things for everybody to play with. So we're trying our best to like show examples of the actual activities. And at the end, we'll have opportunity for you to play with some of the digital or online ones.
And we do have handouts that Kim is going to share at some point so that you have access to copies you can download.
They should be in the chat right now. So if they're not, somebody let me know.
So first up, we really love sleeve activities for many classes, not just Trig, but Trig especially is beneficial. So these are plastic sleeves, and you can put different handouts inside of them, and then students can draw on top of them, and they dry erase very easily. So this is a good alternative for the non-permanent vertical surface we hear about in the building thinking classroom setup. It's non-intimidating for students because they can erase mistakes very easily.
And the one example we have here, and it's not showing up real well, but vector math works really well as an introduction. You can have different vectors and have them do the scalar multiplication, the addition, the subtraction, and experience that. And the other good one that we have is the transformations of trig functions. And that's attached in our activities where they go through and they can, shift it up, shift it down, compress and see the change in the period and all that. And it's very interactive. They really get to talk. I purposely don't do the scale in every pi over 2 so that they intuitively can learn estimation skills on what is pi over 2 and whatnot. And the other thing you can also do with those is we have blank unit circles, so you can print those out and put them in a sleeve so that they can go through and do that. And if you don't have money for sleeves, you can just use Ziplocs.
And people often ask us, I was going to say another really good application for the graphs is when you're introducing or learning the relationship between inverse functions, reciprocal functions. So the relationship between sine and cosecant or cosine and secant is a really good way to have students play around with that. We've gotten asked a lot, where do you get those? And you can literally just Google dry erase sleeves and it usually pops up.
I know a lot of us do guided notes and we have foldable booklets and they're in the handout. And here's an example of one. And this one's actually in the rotation of axis so that they go through, they have all their definitions and we have directions on actually how to make them. There's no staples or anything involved. And it's great for a recap, review. And then we also have one in the attachments for every trig function. So it's a good opportunity to do that jigsaw where you put them in different groups. And one group can do the sine, one group can do the cosine, one group can do the tangent and so forth. And then you can pass out the booklets and then they can go through and teach the booklets and have the other groups fill out the booklets. So that's one of the fun activities we really.
So we do have one for sine, cosine, and tangent. And again, that's shared in the handout with directions on how to put them together. We like these so much that during the pandemic, we actually made these and put them in old-fashioned mail with a stamp and sent them to our students. So we thought that was it was important enough to do that because students tend to like this activity. It helps them organize those notes. And we like it for that. Another activity that we really love is Two Truths and a Lie. I hope most people are familiar with that game where you give 3 statements, 2 of them are true, 1 is a lie. I love doing this with all topics of math. It works great in Trig. I do it a lot with calculus as well. But we give students, a graph or a statement or a problem in 3 statements, 2 are true, 1 is a lie. And that's a good opportunity for those little mistakes that they tend to make, where sometimes it's just reading carefully. Is the word choice on or off? Is the sign positive or negative? Did you switch your coordinates? Those little types of mistakes that students tend to make is a good choice for the lie. We do have them correct the lie. And not that I know this from experience, but sometimes if you have one where there's maybe two lies and one truth and don't tell them that, either on purpose or just it happens, that's actually a really great conversation starter where they have to start, wait a second, is that, I think both of these are wrong. Yeah, it is, but it's a really good conversation starter to throw a little twist in there, either on purpose or just happens sometimes. It also converts really, really well to an amplify activity, which used to be Desmos, so we're still in the habit of saying that. But it works really, really well to convert that to an online activity. And we have an example of that in a slide later on. Anything else you want to say about two truths and a lie?
No, it's just a really good conversation starter for the students to really get them active and engaged in the math. And I like it better in person versus on the Amplify, but the Amplify is a good alternative because then they really get into correcting the lie and figuring out how to fix it so that it works. And we have like little cards that we pass out and they go through and fix each one along the way.
Yeah, and doing that in groups or pairs works really nicely too for the discussion.
The two tri-labs we actually got years ago at an AMATYC conference, and it was like the last session on a Sunday. We went to it before we had to catch an airplane, and it was one of the most beneficial ones that we had where you think of activities, and this one that you see here is basically on the inverse trig, where students are doing the wrong thing on purpose, and then you have them work through the first attempt, and I usually have them do that right at the end of class and then turn it in. And then you give as little feedback as possible. Like you'll circle where the error is, and then and do a little arrow to the second attempt, and they only have to redo the ones that they had issues with. And it works great. I've got one for vectors as well. And it's a really good opportunity for them to learn from their errors and realize that mistakes are very valuable.
And it's a good low stakes concept check. And minimal effort on your part because you're not the feedback is you missed something somewhere. And then they go back and fix it. So hopefully by the second attempt they've got it corrected. So it's not terribly grading intensive.
We love circuit activities, and it has to do a lot with that vertical in the classroom. And on the circuit activities, you put up the problems around the room. They can start anywhere they want. They complete the problem and then they hunt for the answer. And we usually put them up. We've got whiteboards all around the classroom and we'll tape them up, and then the different groups will start and work on different things. And it's just a really great activity, a good review, recap.
So for basic problems, we've also done it with trig proofs and the steps of a proof. That's also a really good one. Or I may be getting ahead of myself, think of another one, but
I don't see the chat. Sorry, we're missing the chats.
Yeah, if there's anything we need to stop and answer, let us know.
Yeah, I don't know how to get to the chats.
This is also, you can modify it for Desmos or Amplify as well. It's not as effective, but sometimes you do the best that you can. But you can kind of emulate this process and Amplify. It becomes more of an individual task at that point, but it can be modified. And we've got an example of that later on as well. We also really love sorting activities. I'll let you.
So the one, and we got this again at AMATYC years ago, and she shared all the resources. And if you Google, you can actually find them, and we have them included in there. But one of our favorite ones is, and it's not listed, is the Tarja puzzle. So we have a Tarja puzzle here where they connect the trig equations with the answers. And then that middle one is a sometimes, always, never. So I don't know if you can see this one, but it's secant squared equal to 1/4 x. And that's an example of never. And the students will sit there and talk about that. And they'll have to take that trig statement and determine whether it's never true, sometimes true, or always true. And if you look at the one where it says sine x plus cosine x equal to 1, that would be one that I would classify as sometimes, because what happens at 0 or what happens at pi over 2. So it really gets them talking. And then there's some where they'll have to solve the trig equation to determine, well, is it always true, sometimes true, never true? So they're just great conversation.
Well, and my favorite is when they surprise me with something sometimes. Like I'll look at it and just out of habit, I think, oh, well, that's a always or that's a never. And then I love it when they find ones and they're, but what if? And those are our teachable moments that I think we all live for. When they start going, but what if this happens? And sometimes they found some that I was like, had to change my mind on and say, oh, that is a maybe. And I was able to finally get our chat up. I will say someone said they had a hard time finding some of the activities in Desmos. Um, our email will be posted at the end, so if you want to email us, we're happy to share some things that way. And I think there was a question about can we get more detail and see a sample? I think that might be on the foldables, which is in the
Yeah,
chat.
yeah, and I was going to say, and I think you actually kind of answered that one, so that I didn't.
Okay.
Okay.
So.
It was popping up and we couldn't get it open before it disappeared, but I've got it up now.
And then folder activities. These are really good for application trig problems, for solving trig equations, for trigonometric proofs. And basically what you do, and we're going to pretend like we're each a group. So you usually pick, depending on how big your class is, 8 problems, 8 folders, and then each folder you'll have the question blank. And then we start off, so I'll start a timer and I'll work on the pink, Cindy will work on the yellow, and then the timer goes off, and the goal isn't to finish it, the goal is to see how they can work together and come with the process, and then they'll put their solutions inside the folder, like Cindy's just doing, and then we switch. And it goes around the room till, and everyone, same amount of time, and when you get back, then the group opens up and looks at all the different methods, and then they analyze which one they think is the best, and then we present them to the class sort of in that gallery moment and put it up and then talk about it. And it really teaches them communication skills, working together, trying to evaluate.
And the whole point is when they finish the problem, they put it in the folder, and when they switch, they're not allowed to peek. That's important. No peeking at other students' work. So then at the end, you get back the one you started with, and it's students. It's really interesting to hear the responses going through and seeing how different groups started a problem or solved a problem, and then they get to decide which one
They like
was most efficient or most creative or whatever. And so it's a good way to compare work too.
And I've learned to tell them not to put names on it, and then they'll try harder because then nobody will know which group worked on what problem except for the group that was doing the analyzing. And this is some of our other favorite activities that we didn't have time to bring in November, but we've got here. And one of them is, creating the unit circle. And you can email us. This was an activity that we found online. And they really see the reference triangles and how it relates to the unit circle when they actually construct them by hand. There's always the entrance and exit tickets, the low stakes, and you've heard lots of people talking about them, but it's a really good way to quiz, but not have it worth a grade, and then you can really gauge where the students are. And then we had our construction group make a circle, and then from here, we have an activity where they can really get engaged in measuring and finding out the difference between degrees and radians and what they actually mean through measurements. So that's
Yeah, so this was actually, I think it came from AMATYC too at some point, some variation of it, but there's a little string on here so they can measure what the radius is and then actually wrap it around, and it's hard to show, but actually wrap it around the edge of the circle so many times and then measure it so that they see the relationship between the radius and how many times it wraps around the circle and the relationship to pi.
and my students won't use the string, they like the measuring tape, but
I don't give them the measuring tape until after they've tried the circle.
but those are some of our other activities that you can, if you have a construction management group like we do, that they just, we
Where's our
asked
dad?
and they made them. So,
And then of course, age of AI, and this is on everyone's radar, but AI is getting better at math. At first, it was very bad at math. So this was an example I found a while back. There are some errors in here. And these are also like our golden teaching moments, right? Like that's where the teaching lies. When we find these mistakes, and I really like finding mistakes that AI makes and giving those to students as a lab problem or a forum post if it's online. I've even used these as test questions in an online class, and I'll ask them, what did the AI do right? Or where could it improve? So sometimes I give one where it's done correctly and they just have to analyze, well, they did this step well and they did this step well. But when it's wrong, they can point out all the things that are wrong. So my trig's a little rusty.
So we know
Yeah.
that there's tons of ways to use AI, but that's like how we like to incorporate it, that they're analyzing what they've learned and why it's so important to learn it.
But trig tends to be a good one where the AI screws up some. So those are fun. And it's also fun to have students try to find them and turn them in. And they'll put their homework in and then like, oh, I got that wrong. So here's where AI messed up. And then we made some examples in Amplify just to see how they're converted. And it's not the full activities. We're happy to share the full activities. Send us the email. We're glad to do that. But if you want to see how some of these translate to Amplify, formerly Desmos, we do have this class set up if you want to log in and play around with some of them.
And we'll pull that up as well because we felt it was time for you. You can't play with the actual manipulatives, but we thought it would be fun for you to play with some of the examples we were talking about.
Oh, wait. There's my student version. Any questions for us? I'll tell you when we did this at AMATYC, we did it in a 20-minute session. So we may have flew through some things, but anyone else have trig ideas that are similar or not that they want to share? How will you use them in a virtual class? I don't know by virtual if you mean completely online or in a hybrid setting, where you might have some students online and some students um, in person, but I think a lot of them are adaptable.
We have an example of the circuit activity in this Desmos so that you can see we basically do an ordering.
Yeah, so there's an example in here. It'd be 7.
Yep.
So here's an example of the circuit activity online. A lot of times I'll do these as lab activities. I don't teach trig online, but I teach Calc 2 online. I use a lot of these Amplify activities for my labs. They also have places in here where you can ask students to explain their work. So I actually get a really good gauge of what my students are thinking when it's in this format.
So for example, they want to solve this and pick this problem first, and they solve that, then they look for the answer and link it. And then when they get to the end, the answer on the last should match with the one that's first. Hopefully that answered that question.
Here's an example of our 2 truths and a lie online, so they can check which one's the lie, but then they have to explain it, why it's the lie. And then that's just another, oh, I thought I had 2 truths, 2 of those. This one before.
Yeah.
Yeah, so that's just another different layout for the answers. Yeah, thanks for that, Gloria. Yeah, a lot of these again, I haven't taught how trig in a while, Tammy has, but I use a lot of the same things in Calc 1 and Calc 2.
On some of the activities, we do have it self-checked. On others, we like to check it ourselves because we found that depending on what it is, sometimes they'll just try it till it says it's right and move on. So we've learned some of them self-check, some of them don't.
I really like to go back in and give feedback on their slides. Like sometimes if it's a card sort thing, have that self-check, that's fine. But I personally really love going back in and giving feedback in Desmos. There's a way to do it where if like 5 students make the same mistake, you can give them the same feedback at once. But it really lets me know what my students are thinking and what where they're making mistakes. Like I feel like I get to know my online students so much better by giving them the feedback in this platform. And they tell us stuff too. Like I always do like check-ins, like, oh, how did you feel about this lab? Or what did you learn? Or what's the most challenging? And they'll let loose.
Oh yeah, they don't hold back.
And they can go back in and check the feedback as well. There's some examples in here of card sorting. We love that too, just for
The other card sort better. Yeah, that one.
okay, we like this one better. Yeah, so just deciding this is law of sines and cosines and how many triangles do you get out of the situation? 0, 1, or 2. It's just a good, quick self-checking.
And then there's the sometimes, always, never.
Yeah, there's an example of a sometimes, always, never. I think this is the exact same as the physical activity that we have. We just made it in a card sort pretty quickly.
And then there's a sleeve example. The next one's a sleeve example.
Yeah. So instead of using the sleeve, we could do a sketch and amplify as well. They can sketch on this graph. We can put in some asymptotes.
George, I love the donkey theorem. I'm going to use that.
Yeah. Well, like I said, I'm gonna switch my screen view. There's our emails. If you want to email us, we'll be very, very glad to share those activities.
Oh, I can add you to our college, our Trig activity base that we have. Oh, and I think he was asking for the other one, so
Oh.
go back
For this one.
for the code. The
Oh.
code's right up.
And Jennifer put it in the chat as
Okay,
well.
thanks.
Thank you. Yeah, so this is just a sample of activities, but we can send the full ones. I'm gonna throw Luke under the bus too.
Yeah, Luke Walsh, if you search his activities, he has his entire Trig course online with activities.
He's a North Carolina buddy, so we can we can throw him out there. But these are all ones that we've made or have adapted in some way. So. So I think that may be what we have. Thank you all for listening to our session. We're happy to stay around and answer questions or show you more. Yes, can we put up our email address again? Yes, we absolutely can. And again, we'll be happy to share anything.